This is Chapter 4, Goal number 22. We will learn to find the exact values of composite functions that contain inverse trigonometric functions. A couple of things to recall. First, remember that a composite function is a function where one function has been placed inside of another function. Additionally, when you are solving for composite functions that contain inverse trig functions, it's important to first determine if your answer is going to be an angle or the exact value of the trig function. And then finally, it's important to always remember to follow order of operations. So let's take a look at number 1. Recall that when we are solving for an inverse function, the inverse is always equal to an angle. Remember that x represents opposite over hypotenuse of an inverse, and y is equal to theta. So because I see that the outside is an inverse, I know that my final answer will equal an angle measure theta. Let's solve this following order of operations. So we will begin on the inside, and the inside asks us to evaluate the sine of pi over 4. And you've learned and memorized weeks and weeks ago that the sine of pi over 4, or the sine of 45 degrees, is the square root of 2 divided by 2. So we have now evaluated the inside. We will bring down the outside, remembering that we are solving for an angle because we're asked to find where inverse sine of root 2 over 2, at what angle is that value. Remember that inverse sine has its range from negative pi over 2 to pi over 2, which tells me that I will be looking between quadrants 4 and 1. Root 2 over 2 is positive, so we'll look in quadrant 1, and we know that in quadrant 1, sine is equal to root 2 over 2 at pi over 4 radians. Example 2. The function on the outside is an inverse, so that tells me that ultimately we will be solving for an angle measure. To follow order of operations, we will evaluate the inside first. The sine of pi over 4. I know that my reference angle is 45 degrees. We know the sine of 45 degrees is the square root of 2 divided by 2. We do need to determine the quadrant we are located in so we know whether this is positive or negative root 2 over 2. 1 pi over 4 is in quadrant 1. And remember, I'm going on the fact, I'm not explaining everything in detail because we've learned where radians are weeks ago. So I'm going on the information you're already aware of. So pi over 4 is in quadrant 1, 3 pi over 4 is in quadrant 2, and we finally find 5 pi over 4 in quadrant 3. We know in quadrant 3 sine is negative, so the sine of 5 pi over 4 is negative root 2 over 2. Now we bring down the outside, and now we will evaluate the inverse function. Inverse sine of negative root 2 over 2 is equal to what angle? Okay, again, we have to remember to look at our range for inverse sine. Our theta value must come between negative pi over 2 and positive pi over 2. Because we're evaluating negative root 2 over 2, we'll be in the fourth quadrant. So our solution is negative pi over 4. Let's take a look at number 3 and 4. Here we are evaluating cosine. Let's go ahead and review. The range for inverse cosine is 0 to pi. And remember, x represents adjacent over hypotenuse in this case. So we'll be looking between 0 and pi. Let's evaluate the inside first. The cosine of pi over 6, or the cosine of 30 degrees, is the square root of 3 over 2. And I forgot to mention, sorry about that, the outside function is an inverse, which means ultimately we will be solving for theta. So the cosine of pi over 6 is root 3 over 2. And now we bring down the inverse. And now, where does cosine equal root 3 over 2? If we look between 0 and pi, we know that cosine is positive in quadrant 1, but negative in quadrant 2. So our angle will come from quadrant 1, and we know that at pi over 6, the cosine is root 3 over 2. Let's look at number 4. The outside function is an inverse, so we will be ultimately solving for theta. To evaluate the inside first, the cosine of 7 pi over 6. We know that the reference angle is 30 degrees, and the cosine of 30 degrees is the square root of 3 over 2. And now we need to determine the quadrant of 7 pi over 6. So quadrant 1 is pi over 6. Quadrant 2 is 5 pi over 6, and quadrant 3 is where 7 pi over 6 lies. And we know in quadrant 3, cosine is negative. And now we will evaluate at what angle does cosine equal negative root 3 over 2. Again, because this is an inverse function, we have to only search for values between 0 and pi. Because root 3 over 2 is negative, we will go to quadrant 2. Cosine of 30 is root 3 over 2, so we'll be looking for a 30-degree angle in the second quadrant. And in this case, that is 5 pi over 6. Let's take a look at examples 5 and 6 where we evaluate composite functions with tangent. To begin, I check the outside and see that the outside of the function is an inverse, which means we will be solving for an angle. So we'll evaluate from the inside following order of operations. So the tangent of negative pi over 3. We know that negative pi over 3 is in the fourth quadrant. So our function value will be negative because tangent is negative in the fourth quadrant. And our reference angle for negative pi over 3 is 60 degrees. And we know the tangent of 60 degrees is the square root of 3. After we evaluate the inside, we bring down the outside, and remember we are evaluating an inverse, so we have to think about the range of inverse tangent. Recall that the range of inverse tangent is negative pi over 2 to positive pi over 2. And if we plot that on our unit circle, we are reminded that we will be working in quadrant 4 and quadrant 2. So to evaluate inverse tangent of negative root 3, because the value is a negative, we will go to quadrant 4. And in quadrant 4, tan equals negative root 3 at negative pi over 3. Example number 6. Arctan, recall, is equivalent to inverse tangent. So because arctan is on the outside, we will be solving for an angle measure. To evaluate the inside, the tangent of 5 pi over 3. Our reference angle here again is 60 degrees, and we know the tangent of 60 degrees is root 3. Now we need to determine the quadrant of 5 pi over 3, so we give this value the correct sign. We know quadrant 1 is 1 pi over 3, quadrant 2 is 2 pi over 3, quadrant 3 is 4 pi over 3, and quadrant 4 is 5 pi over 3. So 5 pi over 3 is in the fourth quadrant where tangent is negative. And again, we're evaluating the arctan of negative root 3. Because this is an inverse function, we do have to consider our restricted interval. So from negative pi over 2 to pi over 2, we're in quadrant 4. Because the function value is negative, and our solution is again negative pi over 3. Okay, what I would like for you to do is look back over the solutions for 1, 3, and 5, and then check out the solutions for 2, 4, and 6. And I want you to see if you can determine how the solutions for 1, 3, and 5 compare with the initial value in parentheses. And then how do the solutions for 2, 4, and 6 compare as well? And see if you can notice any patterns there. Take a moment and analyze that. What I hope that you've noticed in 1, 3, and 5 is that in number 1, the inverse sign and the sign cancel, and pi over 4 is our solution. In 3, the inverse cosine and the cosine cancel, and pi over 6 is our solution. In number 5, inverse tangent and tangent cancel, and negative pi over 3 is our solution. But this idea of canceling does not happen in 2, 4, and 6. You'll see that even though our initial angle was 5 pi over 4, our solution is negative pi over 4. In number 4, 7 pi over 6, the solution is 5 pi over 6, and then in 6, 5 pi over 3, the final solution is negative pi over 3. So when can you use this cancellation property? When the value that you are taking the sine, cosine, or tangent of is in the range of the inverse function, then you may cancel. So for our cancellation properties, we'll say cancellation rules. When you are solving for inverse sine, if the value that you are given for theta is between negative pi over 2 and pi over 2, then you may cancel. When you are solving for inverse cosine, when the value of the cosine is between 0 and pi, you may cancel. And with inverse tangent, when the value is between negative pi over 2 and pi over 2, then you may cancel. If the value that you are taking the sine, cosine, or tangent of is not in this restricted interval, then you must follow order of operations to evaluate the function.